Hi everyone, we're now on to the second lesson of our chemistry unit in Science 10. And in fact, what I did is I broke this lesson up into kind of two chunks. As you can see, this is properties and classification of matter. This is part one. We're going to be looking at physical properties and chemical properties. And again, I should say that this information has been covered with you in the past. And it also can be found in the textbook starting on page 12, which I have linked in the workspace. So this is information that where you want to be familiar with it, you want to know it. And again, I'm hoping that a lot of this is somewhat familiar to you because of earlier courses you've taken. Moving right along, we're going to start with physical properties. Physical properties are properties that are observable, measurable, and will stay the same, will keep the same composition. Nothing new is created. Okay, so here are some physical properties: color, size, odor, density, condensing, hardness, luster. The point is, physical properties essentially are properties that you can detect with your senses, that you can measure. Here are some other ones: color, size, odor, hardness. Something here that you should be aware of is that when something changes states, for example, water, when it goes from solid, liquid to gas, that is a physical property because the original composition has remained the same. For example, water is still made of 2 hydrogens and 1 oxygen, so H2O. The point is, it's just changing its state of matter, but the composition of the elements of the atoms are not changing. So that is a physical property. And again, these are things that you've probably come across before. Remember, it's things that your senses can detect and things that you can measure. Here's a little bit more into physical properties, into how boiling and condensation work. Now, this is something that I'm sure you've come across before, moving between solid, liquid, and gas. Boiling point is a temperature at which a liquid turns into a gas. So if we're dealing with water again, which is H2O, remember, all of these little particles are going to be particles of H2O. Remember that boiling point is when you go from a liquid to a gas. And essentially what's happening is the particles of water, the H2Os, are gaining enough energy to separate and move apart from each other. And of course, that would happen at a temperature of 100 degrees Celsius, give or take, depending on where you are on planet Earth. Condensation point is a temperature at which a gas turns back into a solid. So it is possible for these in gas form, remember, each of these is an H2O. If they are cooled, if they lower in energy, they will form back into a liquid. So remember, boiling point is when you gain enough energy for the H2O molecules to gain energy, move apart, and separate. If you take away that energy, go below 100 degrees Celsius, they will condense back into a liquid. But the main point to understand here is that we still have H2O molecules. It's still 2 hydrogens and 1 oxygen. It's just essentially the energy involved. And if they're over a certain point, they boil, it turns into a gas. If you return down below 100 degrees, the particles, the molecules move back closer together and form a liquid again. If we look now at melting point is a temperature at which a solid melts or changes into a liquid. So again, if we're using water, H2O, we know that the melting freezing point should be right around 0 degrees Celsius based on where you are on planet Earth. If you melt, you're going from a solid into a liquid, so think of ice. If we add energy, we add heat, and energy goes up, temperature goes up in the spring, the temperature goes above 0 degrees, enough energy will be added so the H2O molecules can kind of separate from each other and move around a little more freely. They lose their solid state. On the other hand, freezing point is when you go below 0 degrees. What happens is the energy lowers enough that all the H2O particles line up and essentially form a solid mass. And of course, not to be repetitive, but we know in each case, we're dealing with H2Os. It's just simply how they are relating to each other based on the temperature or the energy in question. But again, these are all physical properties. Another physical property is malleability. Malleability is the ability to be beaten or rolled into sheets without crumbling. So as you know, if you look at copper metal, This maybe isn't so useful to us as humans, but we do have the ability to roll it out, to flatten it, and it doesn't crumble. It maintains some sort of solid structure that we can shape into what would be useful for us. Okay, so for example, aluminum hockey stick, we can take the aluminum, we can roll it out, we can flatten it, and what will happen is we can put it into a shape that is more desirable. So that is malleability. Then you have ductility. This is the physical property of matter that describes its ability to be pulled into a wire. So if you look here, if you look at this metal, what's happened is we can pull it and make it into a wire. That's being ductile. Again, here we have our three states of matter. You have solid, liquids, and gases. Just remember that when you are a solid, and as you move, if you move in this direction from a solid to a liquid to a gas, remember you are going up in energy. Okay. If you want to think of temperature, you're going up in temperature because an increase in temperature is an increase in energy. If you're going from a gas and then you're going towards a liquid and then back to a solid, that's going to be a decrease in energy, or that'd be like going outside and the temperature is getting colder and colder. Think of a lake. The lake might be, think of, you might have hot gas particles in the atmosphere. They might become colder and colder and fall as rain. That's a liquid, and perhaps it gets cold enough that those water particles, molecules freeze together and become ice. I think we've covered that enough. That's pretty self-explanatory. Another physical property is solubility. This is the amount of a given substance that can be dissolved in a certain amount of solvent. For example, think of adding salt into water. When you add the salt into the water, it appears to disappear, or it dissolves. So that's solubility. It is the amount of a given substance that can be dissolved. So for example, if you put salt into water, a certain amount of it will dissolve. That amount will change based on various factors. It could be the substance that we use as the solvent, for example. Right now we're using water. Maybe we change that to something else. Now the amount of salt we can put in and dissolve will change. Perhaps it's a temperature. Perhaps it's the amount that you stir. The point is, I just want you to know what solubility is. Solubility is a measurable amount. You can measure it. The amount of a given substance, like salt, that can be poured into a certain amount of water. Chemical properties are a little more exciting, perhaps. You have, here are your main ones. You have the ability to burn, flash point, behavior in air, reaction with water, reaction with acids, reaction to heat, reaction to blue and red litmus. Those are your cool chemical properties, okay? Chemical properties, the ability to burn. Combustion. This is a process in which a substance reacts with oxygen and produces heat and light. And what I like about this, everyone, you can see the chemical property, things have changed. If you look, here's methane. This is natural gas that heats your house. There's been a reaction that's taken place. These atoms, everything is mixed around and we get new products. That is a chemical property. Burning is when essentially what we had in the beginning no longer exists at the end. That's a chemical property. That's called combustion. We'll learn more about that later. You also have a reaction with water. That's a chemical property, rusting. If you look here at these metals, they certainly are not what they used to be. Okay, rust is a general term for a series of iron oxides formed by the reaction of solid iron. Like, look at this. This is solid iron, but something has happened. It has reacted with the water, and it's no longer regular iron as we know it. That's a chemical property. The original iron has changed. Something has happened. And finally, this is kind of going to go along with acids and bases. This is a reaction with litmus paper, a test in which the red color indicates that the substance is an acid. Blue means a substance is a base, and no change means the substance is neutral. Essentially, what we're showing you is you can test to see if something is an acid or a base by using litmus paper. We'll talk about this more in the future. The main point to be aware of here is, do you know what physical properties are, and do you know what chemical properties are, and can you differentiate between them?